Encryption algorithms can be divided into two main categories, symmetric and asymmetric. Symmetric encryption is all about using the same key for both encryption and decryption. It's often referred to as a shared secret encryption because both parties need to have the same key. For example, if a message is encrypted using the key Apple, the recipient would need that exact key to decrypt it. This approach works great for small groups. If Alice and Bob want to communicate securely, they can simply agree on a single shared key. However, if a third person, Charlie, joins the group, things start to get more complicated. Now we need a separate key for Alice and Charlie and another one for Bob and Charlie. As the group gets bigger, the number of keys required grows exponentially. For instance, if there are 10,000 people in an organization, you'd need nearly 50 million keys. Managing and distributing that many keys becomes a nightmare, especially when new users are added. This is where asymmetric cryptography comes to the rescue. Instead of using the same key for encryption and decryption, it relies on a pair of keys, one public and one private. The public key can be shared with anyone, while the private key remains secret. If Bob wants to send a message to Alice, he encrypts it using Alice's public key. Alice then decrypts it using her private key. It's important to note that the two keys must belong to the same pair. This approach eliminates the need for an overwhelming number of keys, since each user only needs a single pair, one public and one private key. While asymmetric cryptography is slower than its symmetric counterpart, it solves the problem of key management for large organizations, making it far more scalable. Symmetric encryption is faster and efficient for smaller groups, but as the group size grows, asymmetric encryption becomes the practical choice.